Hello and welcome. Here's our graduation project for the Automotive Embedded System program powered by the National Telecommunication Institute and the Ministry of Communication and Information of Egypt, which is a self-driving car Level 2 with a feature-on-demand application. Our project is a proof of concept of a self-driving car featuring lane keeping, lane departure, adaptive cruise control, collision avoidance, blind spot, emergency brake, sleep mode, rain detection and Autowiper, temperature detection and auto AC and feature-on-demand mobile application. Almost all vehicle accidents are caused by human error which can be avoided with advanced driver assistance systems, also known as ADAS. The role of ADAS is to prevent deaths and injuries by reducing the number of car accidents and the serious impact of those that cannot be avoided. The ADAS systems are passive and active safety systems designed to remove human error when operating vehicles of many types. The ADAS systems use advanced technologies to assist the driver during driving and thereby improve the driver's performance. In our system we use LIDAR, ultrasonic, 2 IR sensor, power motion sensor, rain, temp, servo, DC fan and motor drivers. So first we develop an overview of what a car should do in the system. First the car will drive and keep the lane and should maintain the velocity according to his setting or based on forward vehicles, and if there an obstacle in their range the car should react and avoid it by changing its lane, but if there was no lane and there was an obstacle the car have to apply the emergency brake, which all these data provided by Blindspot. The process starts by testing the low-level component and make sure that making their function correctly, such as the motor. The LiDAR interfacing with UART correctly, after that get range detection and mapping the surrounding. Another process which is the analog to digital converter, the analog sensors like rain, temperature interfacing with ARM microcontroller at first time each sensor alone and monitor the output based on action, analyze the data by their resolution and the step size. The next step is both sensor on the system by using the scan mode in STM32, which enable multi-conversion without reset the conversion over and over, and that's one of the reason why we go to ARM. In addition to that, support up to 4 timers and 16 ADC channel and 3 UART, and here we can monitor both sensor together. Wiper aka servo motor and the AC aka DC fan depending on different action. Once the low level is done, high level comes into action, so implement every feature on the system and fix their bugs and test the algorithm once has been validated. The cycle will go on to all the features such as lane keeping, collision avoidance, sleep mode and emergency brake. Once the all features was done their tasks and fulfill their output, the system was ready to run all tasks. As self-driving car was the last trend on the automotive, there are a new services will come to the market soon, which is the feature on demand, which is the user can select how many features he can use and pay for it. He shouldn't pay for services he barely use it. In our car it has a mobile application to monitor the system data and enable or disable the feature that's happening by using Wi-Fi module, which first connecting with the internet and then transmit the data over the internet server, and the application will fetch the data and vice versa.